This conference will now be recorded.
All right. So first thing you guys need to remember is what are packages. Okay. So think about this like everything that you have in your apartment or house has its own place, right? Now, if you want to look for spoons, where do you go?
Kitchen.
Kitchen. And if you want to look for your car?
Garage.
Garage.
Garage. So as you already see here, everything has its own place. It's easy to find things. It's easy to remember where you keep all your things. Okay, so being organized is always a good idea. Okay, so think about packages, something like that. Okay, so on a website, there are several components that basically are designed to show your website. Okay, there is a login page, and then there is a shopping page, there is a payment page, shipping page, right? So for all the components of this website, you have to write certain programs. Okay, you have to write a class for login program, for forgot password, for registration. Okay, you need to write a program for shopping, add to cart, remove from cart. You need to write a program for checkout, payment, credit card, PayPal. Okay, so all these programs are related to each other. Okay, and you group them or organize them accordingly. Okay, so that's what package is. Package is a way, if think about package like a folder. Okay, so when you're doing something like this, don't you organize all your files in some folder? All the music files goes in music folder, all the video files goes in video folder, all the study material for your Java training goes in a Java folder. So you're organized right here. Similarly, packages, think about packages like a folder. Okay, so as you see the symbol, it looks like a package, right? Courier packages. The symbol looks like a package, courier package. Okay, and that's what we call them. We call them packages. So you package or group together all the similar classes in one folder. The more technical word, one package. Okay, so first question is, how do we write a package? What name do we choose? So a typical website has a URL, right? So www.amazon.com. Okay, so technically what we do is, if you work for Amazon, okay, so we reverse the domain name. Okay, so the package name usually starts like this: com.amazon.login, com.amazon.shopping, com.amazon.billing. Okay, these are what we create different folders for, different packages. Okay, the name of the package should be the website name in the reverse order. If you work for chase.com, the name will be com.chase. Okay, if you work for eBay, the name will be com.ebay. The further categorization allows you to be more specific. Now let's say you have a program called registration.java. Okay, that goes under the package login. What else do you see on the login pages other than registration and of course login? What else do you see?
Forgot password.
Forgot password. Okay, forgot user ID. Okay, so these are different programs that allows you to write code for different features. While they register, what do you do when you how do you process the registration request? Okay, what is the program, what is the code you write for registration, what is the code you write for login? All these are related, or they are links that are seen in the login page, right? So what we do is we create a package or a folder called com.amazon.login, and all the related programs on that web page or that feature will be grouped under one category. Similarly, for shopping, you might have something like browse.java, okay, add to cart.java, reviews, you see reviews on shopping pages, okay, or you see product description. So all these programs are usually used on the shopping section of the website. So what we do is we create a package called com.amazon.shopping, and we create all the relevant Java files inside that package, okay? And same goes for billing. So this is how we usually design our project setup, okay? Now that you know how to name it, let's see how to create that. Just like how you create a class, right click, new, and class, there is an option called package, okay? You can create a package and you can name it, okay, package A, and package B, okay? So we are creating packages here. Now once you create your packages, your folders, your groups, then you can start creating classes inside that. Okay, right click on the package and say new class. Okay, so if you see under this package, we have a class called parent. Okay, now you want to create one more class under this, right click, new class. Okay, so this is how we create classes. Now that's all about packages. Okay, so now why is this important for access privilege? We'll see that now. Okay, now all the programs that you have been creating, you always used to write public void, public class, public static void main, and all that, right? So that's what is called as access privilege. Okay, access privilege allows you to implement the encapsulation abstraction features. You can hide certain programs from other classes. You can expose certain attributes and methods to other programs based on whatever information you're storing. Okay, so you decide what needs to be hidden and what needs to be accessible. Okay, so for that purpose, what we'll do is we'll come up with few scenarios. Now, if there are two classes, class A and class B, they can be either related, okay, by saying extends, class A and class B can be related. Okay, if you do not extend, they are basically unknown to each other. Okay, they are just two separate programs. Okay, class A and class B can be either related to each other by the extend keyword, or they might not be related. Okay, so what we'll do is we'll create this scenario. There is package A and there is package B. There are two programs which are related to each other, parent and son. And then there is another program which is not related at all. Okay, now in package B, we'll have another program, son, okay, which is related to your parent class. Okay, and then a totally unknown program, unrelated program. Okay, now this is a scenario that you have. We have two packages, package A and package B. Okay, parent class has two child. Okay, this parent class has two child, son in the same package and son B in another package. Okay, parent class has two child, son in package A and son B in package B. Okay, other A and other B, they are not related at all. these two classes, other A and other B, they are not related to parent class anyway. Okay, they are not related at all. So everything is with reference to this class. Okay, everything is with reference to this class. Two classes are related to parent and two classes are not related to parent. Okay, this is the setup. Now let's see what will happen when you have different access privileges and how they impact. Okay. Okay, these two are in different package, package B, package B. All right, so until now you guys never saw this first line package. Okay, you never saw the first line. Now that we are creating classes in a specific folder, in a specific package, you will see this line coming up, package A. Okay, so this is what tells you which folder or which category or which package this class is from. Okay, so three programs, parent, other A, and son A. All of them are from package A. And then you have other B and son B. They are from package B. Okay, I'll tell you why we are doing this in a minute. For now, just remember 5 classes trying to access each other's variables and methods. How do they impact? Okay, when you want to call a variable and method from one of the class, how do you access them? Hence the name access privilege. All right, so we have 3 classes. Let me put it here. This one goes down. All right, so son A extends parent. And son B also extends parent. Now, this is a line that is unknown to you guys, import. Okay, so far all you guys did was these lines. Now you know what are the 2 lines that are coming up. Package, the very first line tells you which group or category this class belongs to, okay, or where it is declared, where it is created. The package is package B. Son B class is created inside package B. So if you notice here, son B is inside package B. Okay, son B is inside package B. Now when you create classes here in the default package, you will see that there are no package statement at all. Okay, so there is no package line here. Until now you guys never had this line at all. The reason is because you never created a package and you never created a class within it. Okay, ABC class has no package line because it is declared in, it is created in default package. Okay, so this folder that you see default package, this folder, if you create a class in this folder, that package line won't exist. Okay, that package line won't exist. Only if you create a package and then you create class inside it, then you'll see these lines. Okay. Now, import statement. You will require this program, this line, only if the class that you are trying to use is in another package. Now look at this thing. Compare Sun B and Sun A. What are the differences in these two programs?
Then different package.
Different package.
What else? Do you see any lines missing in Sun A class?
Yeah, import package.
Import line is missing here, and import line exists here. The reason is here we don't need import because parent class and Sun A class, aren't they both in the same folder?
Yeah, same package, yes.
Okay, they are in the same package. Sun A is also in package A and parent is also in package A. Since they both are in the same package, you do not need the import statement. Okay, whereas Sun B requires the import statement because
It's in different package.
they're in different package. The Sun B class is in package B and the parent class is in package A. Okay, so you'd require an import statement only if the program that you're using, in this case, Sun B is utilizing the parent program. The program that you're utilizing are using for some reason, maybe extends or creating, instance variable, whatever the reason. Whatever reason you're creating using the other program, if it doesn't exist in the same package, then you need the import statement, or else you don't. So is everyone clear on what is the package statement and the import statement?
Yes.
Okay. Now we'll declare 4 variables. Okay, we'll declare 4 variables in the parent class. 4 variables for 4 access privileges. Okay, we have 4 access privileges. Let's see each one of them. We have public, and we have private, then we have protected, and finally we have package level, default package level. Okay, so first thing, the Sun A class is extending parent. If I have to access the A variable, how do I access it from the other class? It is extending parent class. How do you access a variable from other program? Here.
Sun A dot super dot A.
Come again?
That would be like Sun A dot super dot A.
Okay, you want to do sys out and then print super.a.
Yeah, you can do that too. Yeah.
You can just write A, that should be enough.
Okay.
Okay. Super is only used if if there is a conflict between parent and child.
Okay.
Okay, here you're just inheriting the A variable. You're inheriting everything from parent here, isn't it? So basically, like, these all are part of Sun program anyway.
Okay. Yeah,
Okay.
that's right.
Now, why didn't we create an object of parent class? Because they are related and you already inherit them. It's as if like this was part of this class. You inherited basically everything that the parent has. Okay, so that's why you didn't have to create an object. Here in this program, other A, if I have to access the A variable, how do I do that? I'm
Need to
not related.
create a reference of parent.
Very good. Okay, if the program is not related to other program, you cannot just say sys out A. Okay, that don't work. It worked for Sun program because
It extends from parents.
it extends parent and it
Inheritance.
inherits everything. Okay, you're inheriting everything from parent, so you didn't have to create an object. You just say A. You inherited A from parent. This class, on the other hand, is not related to parent. You did not inherit anything. The only way you can do that is by creating a reference variable, initialize that reference variable, and what do you do? How do you access that variable now?
par.a.
That's it. Okay, that's what we do. Now to access C, what we are doing here is parent class has certain information. Okay, parent class has certain information, A, B, C, D. What we are trying to see is how can these variables be accessed by a related class in the same package, by a related class in other package. Okay, by an unrelated class in the same package, and by unrelated class in a different package. Okay, it all matters when it comes to access privilege. Access privilege is something that how can you access a variable from other class? That's what access means. Okay, how can you access A from this program? What privilege does this program has over the A variable? What privilege or permissions does this program has over variable A? Access privileges, what are the permissions you have to access a variable or method from another program? Okay, what are the access permissions you have to access from other program? That's what it means. Now, there are 4 levels of access privileges. Okay, to put them in the right order, we'll go like this. Private first, package comes next, protected comes later, and public comes in the end. Okay, now private means this variable is private only to the parent class. No one else can access this variable. No one can. Okay, so let me show you that. Error. You cannot inherit anything that is declared as private. Private is a personal confidential information of that class. No one else can access that variable or method outside this program. Okay, no one can access B variable outside this class. If you have a method inside this class, you can access it. See, I can access that variable inside the same class. It is private and I can access that. Okay, let me write the names in the right order. All right, so if you declare a program as private, okay, if you declare a variable as private, only person who can access the variable A is the same program. Okay, you can access the variable A from the same program, not even related programs. You cannot inherit anything that is declared as private. See, error. It is not visible. It's not visible because it is declared private. How about a program that is not related? No. How about a program that is not related and in another package? No. How about a program that is not related, that is related and in another package? No. No other program, okay, no other program can access the variable A, no matter you're related, inherited, or you're unrelated. No matter what you do, none of the other programs can access the private variable. Is that clear?
Yes.
Okay. The next one is what we call a default or a package level. Okay, this is a package level variable. Okay, so what is the package of parent class?
Package A.
Package A. Son A class.
Package A.
Son B class.
Package B.
Package B.
Different package. Okay, let's look at this now. No error. The variable B, no error. Variable B is declared as package level. Parent class is in package A. Son A class is in package A. Since they both are in the same package, you can access variable B. How about unrelated class?
Yes.
No problem. You can access that. Even though you're not related, you can still access that. Why?
It's in the same package.
It's in the same package. Okay, all of these are in the same package, package A, and hence this particular variable can be accessed by any class, related or not, as long as they belong to the same package. Now let's look at the other package. Error. You cannot access B variable because it is a package level variable only. You can only access that if this program was in package A, which it is not. How about a related class? This extends parent, right? It is related, but not in the same package. Error. Okay, so when it comes to package level variables and methods, what matters is if the other program is in the same package or not. That's all it matters. If the other program which is accessing that variable, okay, is it in the same package or not? That's all it cares. Doesn't matter if you're related. Even if you're related, it doesn't care. Okay, as long as you belong in the same package, you can access the variable P. Okay, is everyone clear on that? Guys?
Yes.
Yes, sir.
Now protected takes one step further. Okay, we are going in an incremental fashion. This is very limited access. This has a little bit of more access. Similarly, protected is one step higher than the package level. Okay, so what protected can do is it can give you access to any program in the same package level plus related program in other packages. Okay, this is protected. Protected meaning any program in the same package plus any other program which is related. Related as in extends or inheritance. Okay, if there is one more program which is related to parent but they are not in the same package, protected will cover you. Okay, let's see the variable C. No problem, same package. C, no problem, same package. Okay, now this one has an error. The reason is it's not in the same package, package A, package B. They both are not in the same package. And the second reason is they are not related. It doesn't extend parent. That's what protected means. Look at this class. They are not related. No, sorry, they are not in the same package, but they are related. So you do C and no error. That's what protected means. Protected allows you to access within the same package as well as other package, provided they are related, they extend, inheritance. Okay, protected is one step more, one step ahead of package level. Okay, and finally public. Public, as the name goes, it is public. It is accessible to everyone, related or not, same package or not, doesn't matter. If you declare something as public, everyone can access it. Okay, no errors, no errors, no errors, and no errors. Okay, if you declare something as public, everyone can access it. Everyone can. Okay, so these are the 4 access privileges that allows you to control what information can be accessed and what can be blocked. Okay, now this applies to methods as well. Okay, if I declare this method as public, you can access this par.m. Okay, you can access the method m. If I declare this as private, if I declare the method as private,
Only parent can access it.
Only
Only
parent.
error. If I make this as default,
In that package, we can.
yes,
Same package.
no error here, but if you use it here, you'll get the error. Package level. Even here, I'll get the error. Package level. Similarly, if I do protected in these 3 programs, who will get errors? Other A, other B, and son B. If I do protected,
Other B.
Son B. I mean other B.
okay, protected meaning same package, so no problem with this guy. It's in the same package.
And related.
And related. Son B is related, so no problem here. But this one is in a different package and not related. Okay, so other B is the only person who got that error. Okay, but if you do public, everyone is fine. Everyone can access, no problem at all. Okay, so that's what these 4 access privileges are: private, default, protected, and public. They go in the same order. Okay, so private has the least access. No one outside this program can access it. Package or default only in the same package. Related or not, doesn't matter. Then the next highest is protected. Everyone in the same package plus related program in other package. And finally, public. Public has the maximum access. Anyone can access these variables and methods. Okay, same package or not, related or not, everyone can access that. Okay. All right, so you guys need to understand why we need this. Okay, now let's assume you have a program which is for billing or payment. Okay, so there is a program for payment, and you have customer sensitive information, okay, like credit card. Okay, you're responsible to store this carefully. Okay, you're responsible to store this carefully. Now you have a method which allows you to do the payment. Okay, customer payment. So process payment, and what you take is customer's total amount. Okay, this is what you have. Now let's say I'm the other developer who is basically working on the shopping program. Okay, and you are the developer for payment program. Okay, now you have the ownership of this information. Okay, I don't have anything, I don't know anything about customers credit card information. I don't know anything. I belong to the shopping section. So when customer does browsing and everything and says checkout, my job, the shopping program job, is to calculate the total amount in the cart and give it to you. Okay, give it to your program. What you do is you take this total amount, whatever charges are pending, and you file it or charge it on this credit card. Okay, that's your information. So if anything goes wrong with the customer credit card, they are stolen, hacked, whatever, who will it be? Will it be on you, the payment programmer, or will it be on me, the shopping programmer?
Payment program.
Payment programmer.
Payment programmer. So you are responsible for this information. So it's your job to protect that. Okay, so what you typically do is you declare this as public. Is that correct?
No.
No. What does
Private.
public do?
Protected. Sorry. It gives access to
Anyone.
anyone.
It gives access to everyone. Okay, so if I'm the shopper program, if I do like this, right? Okay, so that is your program and this is my program. So when customer says they want to check out, what I'm going to do is I'm going to call your method, process payment. Okay, now if I declare an object, if I create a reference variable of your object, I'm free to access all the information about that customer, right? If I say p.credit card, won't I be able to access that if I make it public?
Yes. Yes.
Right, I can say p.credit card and my program will be able to sneak in and steal your customer's credit card. My program can do that because you declared this as public. So you need to have a healthy mixture of all the access privilege that allows you to give enough access to the user and at the same time protect that is confidential. Okay, in this, if I make this if I make all the variables and method private, is this program of any use to anybody? If I make everything private?
No, just for payment.
No, only the same program.
Only the same program. If you declare everything private, this program, whatever you have payment, is of no use to anybody. Programs are supposed to be accessed by other programs. That's the whole point. One program creates a reference object, calls the method, calls the variable. That's the whole point. A program is only useful if it is accessible by outsiders. If this program has nothing, everything is private, this program is useless. You will never see any program that everything has private. What's the point of having a program that everything has private if nobody can use it? Would you buy a product where you cannot access anything at all?
No.
No, that product would be useless. So similarly, declaring everything private would not be useful either. Okay, so you need to have a healthy mixture of both access privileges. Choose private if you want to keep certain information confidential, hidden from other developers, other classes. So if you declare private, nobody can see what is the customer's credit card. Okay, now we need to make this public because we want our shopping developer to process this customer's charges. Okay, so you need access to the method process payment, but you don't need access to the internal secret confidential information. Okay, so now we have a healthy mixture. Okay, if shopping programmer comes and tells you that I want to charge this customer $1,000, all you have to tell them is just tell me who is the customer and how much you want to charge. That's all. You don't have to worry about credit card. I have that information. I know what is customer's credit card and I know how to charge them. Just tell me how much is the amount. That's all you need to tell me. By doing this, your website is functional because shopping program is successfully able to charge when the customer says checkout. Okay, at the same time, the other programmers are not able to steal this secret data. So you need to have a healthy mixture of public and private. Okay, whatever you want to protect, make it private. Whatever you want to give access, make it public. Okay, you can always have package and protected. Okay, sometimes there is another program which is not in the same package but needs access to customer's credit card. Then you make it protected. But by doing protected, there is a problem, which is another unrelated program in the same package can access as well, right? So you have to be careful when you use these variables: protected, private, public. Okay, so these are the situations when you actually use these access privileges to let other programs access your variables and your methods. All right, so any questions? Okay. Now the constructor, okay, you learned about private and public for variables and methods. Constructor is part of a class as well, isn't it? Constructor is part of the class as well. What happens if I declare the student constructor as private?
Only student class can access it.
And when is the constructor called?
When we need to initialize.
Yes, when you initialize. So from other program, when you're initializing the student, you cannot initialize this class anymore because the constructor has been declared private. So from other program, when I'm trying to create an object of that class, student, I cannot. So if you declare a constructor as private, what will happen? You cannot initialize, you cannot create objects. Okay, but if I do public, no
Yes,
errors. Okay, remember constructors, when you're using access privilege on constructors, you have to be very, very careful. Okay, if you do anything other than public, there will be errors. If constructor is anything other than public, other programs will have error. Okay, you can't create objects of that class at all. All right, so data transfer object, we already covered it. Okay, now remember I gave you the when we were discussing the method signature, every method has only one return type, right? So if you have to return more than one information from a method, how do you do that? Let's say you have a method called getAddress. This method will return street number, city, state, zip code. So can I declare this method like this? Public string, and int. Can I declare this method like this? Because
No.
I need to return street, city, state, zip code.
No.
No.
No, you cannot return multiple output. Return type can always be one, correct?
Yes.
So how do we solve this problem? How do you return more than one information? Is this a simple information or complex information? Is this data simple or complex data?
Looks simple.
No, it's a complex
Simple
data.
meaning indivisible. Simple is indivisible. As integer a equals 10, this is indivisible, simple data. String a equals string name equals John, simple data, indivisible. When I am asking you to return street, city, state, zip code, I'm naming 4 different information. So is that simple or complex?
It's complex this time.
Complex. So if it is a complex information that you need to return, what do we do? This was in day 1.
We need to get the access to the address class.
So you'll create another class called address.
I think yes, we need to create another class called address info.
Yes. You create another class called address and you declare these 4 variables in that class. And here, rather than writing 4, what do you write here? What do we write here?
Void.
This is a simple method signature.
Write their address, their class name.
Why would you write void? When I say get address, you just sit quiet, you don't give me anything. If I ask you what is your address, you'll sit quiet. That's what void means. Since return type is limited to only one, when you want to return a complex data, we create another class which has that complex data written and return that class instead. Please go to our day 1 chapter and look into that. We did the whole thing, okay? Data structure, simple data type. If you have some information which is indivisible, you go with simple data type. If there is an information that is complex, when I say complex, you need to understand what I'm talking about. Is student a complex information or simple?
It's a complex.
It's a complex, so we created another class where we could store the student's name, grade, and age. That's what the relation was. Complex meaning you create another class. You cannot write student as string. Student is just not made of one string value or integer. Can you declare a student variable as integer?
No.
You can't. It is not a one value. Student is defined with more than one information like age or something. You need to have name, grade, age, address. So what we do is, if this information is complex, we cannot use one of the simple data type like integer, string, and all. We need to create another class that can hold that complex information. So we can declare that here. That was the whole point. So every program has a specific goal. Okay, bank has goals: withdraw, deposit. Okay, bank has withdraw method, it has deposit method, it contains balance, account number. Okay, every program usually has a specific role, specific job: balance, account number, withdraw function, deposit function. It has specific job, specific information. What does the address information has? What is the job of address information with respect to whatever we did now? This is what we call data transfer object or data access object or bean. Okay, these programs do not have any specific responsibility. These programs do not have any specific responsibility like withdraw or deposit. All they do is transfer. Aren't you using address class just to return to the caller? Its only job is to transfer. That's what the T stands for. This object is only used to transfer complex information. That's all. Do you see any other use of address class like what you have with bank, withdraw, deposit, or a restaurant class which has buy, sell, menu? Does address class has any specific responsibility? Yes or no?
No.
No. Its only job, the only reason we created this class was so that we can store complex information when we return from this method. We created this class so we could return some information. In another word, we could transfer information from this method to whoever is calling. That's the sole purpose of this class. Such classes are typically known as data transfer object. Okay, there is no specific role associated with this class. Only job of this program is it is used to transfer information from one class to another class. That's all. Okay, whoever is calling this method, they will receive this object, address object, and this get address method will send this object. So only job is to transfer information from point A to point B. Data transfer object or data access object. It is also called beans sometimes. Okay.
This conference will now be recorded.
All right. So look at this class here. All we are using the student class is to transfer information. That's it. Okay, there is no purpose of this class exactly. We are just using it to transfer information. Now, these are the two programs that are talking to each other, the test program and the college program. Okay. Now, if I have to call the, how do I call the method get student from here?
Create object of college.
Create object of college first. Then give me the right syntax. You know how to make method calls.
C dot get student details.
All right.
And the ID we want to.
Is that all? What are the rules on calling methods?
We need to handle the return type.
Yes, you need to handle return type. So what do I write?
Student.
Yes.
In space int.
Student.
Space like the variable
Any variable.
is equal to
Equals to.
Yes. Now if I want to print the name,
just out, sys out st.
see, st what?
Dot name.
Print.
Is that student's name?
Oh. St does. St. Oh, wait.
Again, guys, you need to look at references.
Dot name.
Name.
I passed the ID 1 and the college program sent me the student object. In the student object, it sets grade as 1 and name as John. So when I handle the return type, I print the name, I get whatever the other program sent me. The other program sent me student object with 1 and John. So I handle that in a variable and I can print it. Name, I'll get John. Grade, I'll get 1. In the whole process, what is the one job of student? What is student really doing? What are we using student class for?
For a return purpose.
In other words, we are transferring from here to here, data transfer object. The only purpose of student is to set information and send it back to the caller. We are transferring this information from this program to another program. Data transfer object. That's the only purpose of student class. Again, I'm stressing, guys, look at the reference chapter again. Nobody's answering this properly. Okay, how to handle return types. What is this variable? Why am I printing st.name? Why am I getting John here? Why not Jane or Mike? Why am I not getting Mike or Jane? Look at the reference chapters again. Okay. All right, so polymorphism. We already saw one form of polymorphism. If you guys recall, where did we see polymorphism before?
In
Method of-
interference.
iPhone.
Method overloading.
In our previous chapter, where did we do polymorphism?
Like for the backward compatibility in interference.
In inheritance
Method.
class.
You guys are naming everything that you can.
Constructor. Constructor, I think.
Yes, we did that in constructor. Okay, we did that in constructor where parameters were different. One constructor took string, another took string and integer, another took string, integer and integer. Okay, so we did that in constructor chapter. Let's see what it means. Now, polymorphism is typically defined by the method name and the parameters. Okay. What I mean is, if you declare a method like this, this is not polymorphism. Okay, polymorphism is not defined by return type, but by the method name and parameters. Okay, return type doesn't count. Now, typically polymorphism is doing the same thing in different ways, right? Many forms. So here, just like what we did in constructor, if you notice, the names are same, drive, drive. Okay, but the input are different. There is no parameter and there is an integer parameter. This is what we call overloading. Overloading is a feature where you perform the same operation in different ways, provided the parameters are different as well. Okay, so you have turn. Okay, and here, let's say you have no variable, so it will say turning left. If someone passes you an integer, let's say you are turning right. So this is the same operation, turn. Okay, the main goal is to turn. Now we take a left or right is based on what input you receive, isn't it? If you do not receive any input, you're going to take a left turn. If you receive an integer input, you're going to take right turn. So the same operation turn will take left or right turn based on what is your input. Okay, if no input, we take a right, left. If there is an input, we take a right. This is what we call polymorphism, doing the same thing in different ways. Okay, and that depends on what input you get. Okay, so same operation, doing the same operation in different ways based upon the input. Okay, the same operation turn can be done in two ways based on what is the input. This is polymorphism, doing the same thing in many forms, polymorphism. Okay, is everyone clear on that? Okay. Now, polymorphism comes in two forms, overloading and overriding. So we call it compile time and runtime. Okay, compile time polymorphism is where you can understand, you will know which method will be invoked before even you run it. Before even you run the program, you know which method will be called. Okay, let's look at that. Now, looking at this program, do you have any doubt on which method will be called?
No.
No. Do you want me to run the program to know which method will be called, or by just looking at it, you can guess?
Looking at it, we can guess.
Okay. So in this case, what will it be?
Running.
Turning right. Turn method. We are calling turn method, but there are two turn methods, 1 and 2. Now, the one method that takes integer as the input is the one we are interested in, which is this one. So we know for sure it is going to do turning right. It is going to print turning right, even before I run the program. So compile time polymorphism is, if you have any conflict, confusion like this, it will be resolved even before you run the program. Even before you run the program, you will know there is no confusion for you. Okay, you will know which method is called even before you run, even before you start the program. Okay, this is what we call compile time polymorphism. Compile time polymorphism is overloading. Is everyone clear on that? What is compile time polymorphism?
Yes.
Now, overloading can happen in the same class or in another class. Now, tell me how many method does the Nissan program has? It is extending car.
3.
Three methods. One is its own turn method that takes Boolean, and then it inherited 2 more methods from the other program, from the parent program. Turn with no parameter, turn with integer parameter. So if you just look at this, how many methods are listed?
3.
3 methods. Now if I say turn int no param, what will it print?
Turning left.
Left, turning left.
Left. Okay. If I say true,
Turning reverse.
Turning
okay.
reverse.
So overloading can happen, or compile time polymorphism can be done in the same class, like this one. In the same class, you have 2 methods with same name. Okay, or it can happen between parent class and subclass. Okay, you have the same method name, turn. Okay, but with different parameters. Boolean, no parameter. Boolean, integer parameter. So overloading or compile time polymorphism can happen in the same class or within a parent and child class. Okay, that's a relation, compile time polymorphism. Okay, now let's see what is a runtime polymorphism. Okay, runtime polymorphism is a situation where you cannot predict which method will be called. Okay, you cannot predict which method will be called. All right, so let's do runtime polymorphism now. All right, so the rules are, for overloading, the name should be same and the parameter should be different. Okay, the name should be same and parameter should be different. Now here, in case of runtime polymorphism, it usually happens in child class and parent class only. Okay, it has to happen in two different classes which are related to each other. Okay, and the method signature should be exactly similar like your parent class. So parent says, if someone calls me turn method, I'm going to turn left. Here, the Nissan class decides I'm not going to take my parents' suggestion. I'm going to come up with my own solution for turn method. I won't listen to my parent. I will take a right turn. So this is what we call overriding, which you guys saw in, where did you guys come across this feature, overriding?
Diamond problem.
In the diamond problem, exactly. The default methods, right? So the parent class had a method, so you had to override it, come up with your own solution. That's a runtime polymorphism. Okay, now in an overriding, okay, if this is overloading, turn and turn, same name, different parameters. If this is overloading, overriding is same name and same parameters. Again, this is a contradiction. Okay, the overriding typically happens with only name and this thing, parameters. If you change this, it's not overloading or overriding, neither one of those. So you have to keep the same return type as well. Okay, to make sure you're exactly copying your parent signature and coming up with your own solution. Now here, anytime you do overriding, or runtime polymorphism, I will tell you why it is called runtime polymorphism in a minute. Okay, to identify if this method is overriding or not, look at this green sign. Okay, this green arrow will tell you that you are basically overrule, override your parents' turn method suggestion. You don't want to adapt or inherit your parents' turn method. You want to come up with your own turn method. You're overriding or overruling your parents' turn method and coming up with your own solution. Okay, that's overriding. You can see a green symbol right here. Okay, now the reason it is called runtime polymorphism is we have two classes, car and Nissan. Okay, Nissan is extending car. Now, what are the ways you can initialize the car variable? You guys know this. We did this in inheritance.
Car C equal new car,
And
car C equal new Nissan.
yes, there are two ways to create object of the car, either by passing new car or by passing new Nissan. There are two ways. Okay, so here is our CarMax program. Okay, the Nissan program has a turn method and the car program also has a turn method. Both of them are different solutions. Okay, now this method test drive takes a car object, a car reference variable. Just like here, car C can have new car or new Nissan, either one of them. If a method takes a reference variable car, you can pass either car or
Nissan.
Nissan. You can pass either one of them. Okay, now if the main method is trying to call your CarMax program, the main method has an option. Okay. Here, let's say you have Nissan and you have car. Two different programs. Okay. When you're calling the CarMax method, you have option to send either one of them. You can send C11. Okay. Car 11 is what the test drive needs. So what are we passing? What is the data type of C11?
Car 11.
Reference.
Okay. Here you can also pass N. What is the data type of N?
Nissan 11.
Is Nissan a subclass of car?
Yes.
So it is allowed. Just like here, car C, right hand side you can assign new car, or right hand side you can assign new Nissan, right? Similarly, if a method takes car, remember method passing and initialization, they are both same. Okay, if I want to call the drive method, I can pass either one of them. I can pass A and I can pass B. What you need to remember is these two are the same thing. 1 and 2, they both are same. Just like left hand side car C gets the right hand side new car assigned, left hand side car C, the right hand side new Nissan gets assigned. Okay, right hand side gets copied to left hand side, isn't it? When you're calling a method, whatever you pass, it gets copied on whom? A gets copied to whom? Where are we passing the variable A towards?
Car C, the variable C.
Here. We are copying A to the car. We are copying B to the car. Until now, you guys knew that if the data type is car, you have to pass car. That was the rule, right? This is how we learned until now. If you want to call the drive method, which takes car, what do you send? You send a reference variable, which is also of type car. You guys do remember this, right? If you remember this, only then overriding makes sense. Do you guys remember how to call methods?
Yes.
Okay. If a method requires car object, you have to pass a variable whose data type is also car. That was the rule. Okay. With inheritance, the new rule is if a method requires car, you can pass a reference variable which is of data type car, and you can also pass a reference variable whose data type is the child class of car. Okay, just like this. Until now we knew that if left hand side is car, right hand side we always said new car. Now the new rule in the inheritance, we learned if left hand side is car, you can also send a child class on the right hand side. The same logic applies to methods now. If a method takes car, you can pass a variable A whose data type is also car. The new addition is you can also send any other data type as long as it's a child class of car. Okay, it's a child class of car program. Okay, this is allowed. Now, here in overriding, the reason we call it runtime polymorphism is when you run the program, okay, when you run the program, if here you pass the car 11 object, it will print turning left. If you pass the Nissan object, it will print
Turn right.
turn right. So looking at this program, can you guess, looking at the CarMax program, will it print turn left or turn right? Looking at the CarMax program, can you tell that?
No.
You cannot. When can you tell that? When you run the program. Hence the term runtime polymorphism. Looking at this program, you cannot guess what's going to happen. When you run the program, if you receive a car object, it will call the turn method of car object. If you send the Nissan object, it will call the turn method of
Nissan object.
Nissan object. Okay, that's why runtime polymorphism. Here it is saying turning left because what was the variable I passed?
C11 of car.
Of
Object.
car. I passed C11, which is of type car. So look at the car turn method, it says turning left. What if I pass N? N is a Nissan object.
Turn right.
Turn right. Nissan there.
Okay, so this is runtime polymorphism. You cannot guess what method will be called by looking at this code. By looking at this code, you can never tell what method will be called. You can only guess in runtime. When the actual object is passed to this parameter, if the real object is car, it will call car's turn method. If it is Nissan, it will call Nissan's turn method. Any class you take. Okay, so this is the Toyota car. What if I pass the Toyota object now?
On backwards.
Yes. Did I do any code change to CarMax program?
No.
Do you see the power of polymorphism here? No matter how many programs you add, how many cars you add to your dealership, the CarMax program will never have any code impact, ever. The CarMax program never has to change. If you have 100 cars, how many methods do you need here if polymorphism was not there?
100.
You need 100 methods. Test drive takes Nissan. Test drive takes Toyota. Test drive takes Hyundai. Test drive takes Ford. You would have to write 100 different methods to test drive every individual car. Hundreds of methods. With runtime polymorphism, you will never have anything changed here. You never have to do any changes here. Just add one more program which extends car, and in runtime you pass Toyota, you get a test drive for Toyota. In the runtime you pass Nissan and you get a test drive for Nissan car. This is designed for future. In future you can add 100 more cars to your dealership. This method, test drive method, will have zero impact. This one method will serve test drive for every single car that you sell today and would be selling in future. That's the power of polymorphism. Runtime polymorphism. If you add one more car, in runtime pass one more car, Ford, and you'll get the turn experience of Ford car. This is runtime polymorphism. Looking at this program, you can never guess what's going to happen, which method is being called. You can never guess because the turn method exists in 4 different places. It exists in Nissan, it exists in Toyota, it also exists in the car program. So when you say turn and the bracket, you never know which turn method will be called. You never know that. You will only know that when you run the program. And hence, runtime polymorphism. If I do like this, do you have to guess which turn method is called now? Are there too many methods which has the same signature, turn integer?
No, just one.
No. We don't have turn one here, integer here. We don't have turn integer here. There's only one turn integer in the car program. So you very well know which method we are going to call here. It will be exactly this one, nothing else. Compile time polymorphism. We can know this without running the program. We know what method we are going to call. There's only one method, turn, which takes integer. But this one is runtime. You can never guess which method will be called. It could be Nissan's, Toyota's, or car program, or Ford program. You never know. Not until you run it. Okay, runtime polymorphism and compile time. So let's make a quick list. Overloading, okay, it is called compile time polymorphism because you can guess it even before you run the program. You don't need to run. This is runtime polymorphism. Only when you run, you will know which object it has. Does it have Nissan object? Does it have Toyota object? Okay. Here, method name is same and parameters are
Different.
different. This can happen in same class or in parent and child class. Okay, it can be same class or parent child. This is overloading, same class. We have 2 methods and different parameters. You can also have it here in parent and child class. Same method, method name is same, the input is different. Okay, so overloading can happen within the same class or in parent and child class. Runtime polymorphism, on the other hand, is slightly different. Here, method name and parameter are same. You need to have same method name, same parameters. Okay, method name is same parameters. Method name is same parameters. Okay, it has to have exact same name and same parameter list, empty, empty. And this can only happen between parent and child class. Okay, remember, overriding cannot be done in the same class. You need 2 programs. You need parent and child. Okay, you need 2 programs to make overriding happen. For overloading, you can do it in the same class or in different parent and child class. Okay, overloading, overriding, we are always talking about 2 methods. There are 2 methods which we are dealing with here In case of overloading and overriding, we are dealing with two methods. The question is, are these two methods in the same class or in parent-child class? Okay. For overloading, it can be in the same class, both the methods, or it can be in parent and child. For overriding, these two methods belong one in parent and one in child. Overloading, overriding, compile time polymorphism, and runtime polymorphism. Okay.